Okay, so let's unpack this. Imagine having a super smart AI assistant, right?
Mm.
But it's like it lives in a different reality, completely oblivious to what you're actually working on. It's frustrating, isn't it?
Oh, absolutely. It's like you can write amazing code, but doesn't know the first thing about your project.
Exactly. It's that gap between the huge potential of these large language models, the LLMs, and, well, their often limited awareness of your immediate context.
Yeah, they're brilliant, but sometimes they feel like they're just operating in a vacuum.
Totally. Well, today's deep dive takes us into a really clever idea to bridge that gap. The Model Context Protocol, or MCP.
MCP, right.
Think of it as a way for all your different apps to kind of whisper important details directly into the ear of your AI assistant.
Like giving it a heads up.
Yeah, it's an open standard that promises to make our AI interactions feel far more joined up and, honestly, much more useful.
And what's really key there is that it's open.
Mm.
That's a big deal.
Why is that?
Well, it means anyone can potentially use it, encouraging different applications and AI models to speak the same language when it comes to context.
Whoa, okay.
Ultimately, this could lead to a much more interconnected and, well, fluid AI experience across all the tools we use every day.
Right. And to really get our heads around how this works in practice, we're going to look at a real world example.
Okay.
Our source material for this deep dive is an article called Creating MCP Servers in Swift from April 17th, 2025. It walked us through building a pretty basic MCP server.
A hands-on approach. Nice.
Exactly. So our mission today is to get a tangible understanding of what MCP is all about, how you can actually build something with it, and why this could be a significant step forward for how we interact with LLMs across all sorts of
Yeah,
applications.
I think this practical example is key. It helps move beyond just the theory and lets us really grasp the potential and maybe some of the practicalities involved in actually making MCP work.
Okay, let's get down to it then. What exactly is this model context protocol in like simple terms?
Okay, so at its heart, MCP is like a set of agreed upon rules. Think of it like a common language.
Language for context.
Exactly. It allows different software programs to package up relevant information in the context
Mm.
and send it to large language models in a way they understand.
And main goal.
The main goal is really to make interacting with our tools through natural language much more intuitive.
Okay, give me an example.
Well, imagine asking your AI, maybe inside your text editor, about a specific function you're looking at.
Yeah.
With MCP, it could instantly know which files are open, maybe the programming language you're using, and give you truly relevant help, not just generic stuff. That's the kind of seamless experience MCP aims for.
It's like giving the LLM a sixth sense for what you're actually doing right now.
Pretty much, yeah.
And the article mentions it's intended to work across all sorts of applications, not just code editors, right?
That's the vision. Code editors, IDEs are obvious starting points, but you can imagine it in lots of places.
So what kind of whispers are we talking about? What other context could it get?
Well, think about project management tools, for instance.
Okay.
An LLM could understand the current tasks, maybe deadlines, who's working on what. Or in a design app, it could be aware of the specific elements you're editing, their properties, the overall project style guide, maybe.
Interesting.
Yeah, the idea is that any application where context can improve the AI's understanding and assistance could potentially benefit from implementing MCP.
And because it's a standard.
Exactly. Because it's a standard, developers can build these connections knowing that any AI client that speaks the MCP language will be able to understand and use the information provided by their application.
Right, that makes sense. Now, the article really makes this concrete by showing us how to build a simple MCP server in Swift. They called it the Swift version server.
Yep, a nice focused example.
So how did they start building this thing? What were the first steps?
They began with the very basics, creating a new Swift project. They used the command Swift package init type executable.
Okay, standard Swift setup.
Pretty much. Think of it as just setting up the basic folder and file structure you need for any Swift program that you actually want run from the command line.
Right, getting the foundations in place. And then, crucially, they needed to give this Swift program the ability to speak MCP. How did they do that?
Exactly. The next essential step was to bring in the Swift SDK for MCP servers and clients.
An SDK, like a toolkit.
Yeah, precisely. Think of an SDK as a ready-made toolkit that provides all the necessary components and instructions for interacting with a specific technology, in this case, MCP.
And how did they add it?
They did this by adding a dependency in their package.swift file. That's the file that manages external code for a Swift project.
Okay.
They specified the location on GitHub, https://github.com, model context protocols, Swift SDK, and the specific version they use, 0.7.1.
So it's like telling Swift, go grab these specific MCP tools from this place.
Exactly that. Go fetch version
Yeah.
0.7.1 of the MCP tool so we can use them.
Okay, so they've got the basic project structure and the MCP toolkit. What happens next in the main.swift file? That's where the server code actually lives, right?
Yes. In main.swift, they start by importing the necessary modules foundation for basic stuff and MCP itself, which contains the SDK code.
Right.
Then they create an instance of the server class. This is like creating the main brain of our MCP server.
And they give it a name and version?
Yep, they give it a name, Swift version server, so clients can identify it, in a version 1.0.0, which is just good practice for managing updates later on.
Gotcha. And then there's this capabilities parameter mentioned. What kind of capabilities are we talking about here?
The capabilities parameter. That's basically how the server tells potential AI clients what it can actually do.
Okay.
In this simple example, its main capability is providing tools. So they set up the capabilities with a tools property.
And inside that?
Inside tools, they set list change to false. This is basically the server saying, hey, the list of things I can do, my tools, isn't going to change very often. For this simple server, it never changes.
Okay, so it's like the server announcing its static menu, basically. Here's what I offer.
Exactly. And then they set up the communication method, right? Using something called Stdo transport.
Yeah, what's that about?
Stdo transport is the communication channel. It allows our MCP server to send and receive information using standard input and standard output streams.
Like the command line.
Precisely. The same way your computer often communicates with programs running in your terminal. It's a simple and, importantly, widely compatible way for different processes to talk to each other.
Makes sense.
And finally, they call server.start transport. That's like flipping the switch, turning the server on, and telling it to start listening for requests coming in via that Stdo channel.
Okay, the server is running listening, but it doesn't actually do anything specific yet. That's where the Swift version tool comes in. How did they create that?
Right. So the first step was to define what this tool actually is. They create an instance of the tool class,
Okay.
and they give it a name, Swift version, and a description, which is just text explaining what it does.
Right.
Returns the current Swift version. This is the basic info a client would see.
Now, this is an interesting little detail the article points out. The tool name, Swift version, is in snake case with that underscore. Why is that important?
Yeah, that's a good catch.
Yeah.
It seems, based on the author's experience with the SDK and perhaps some clients, that using this snake case naming convention for the tools helps avoid potential hiccups.
Hiccups.
Yeah, like when the AI client tries to actually call the tool, think of it like making sure both sides are using the exact same unambiguous label. Even a small difference in casing or naming might cause the communication to fail unexpectedly.
Ah, okay. So it's just a practical tip to avoid weird errors. Good to know.
Definitely one of those little things that can save you debugging time.
And they also added something called input schema, even though this tool doesn't really need any input, right? It just gives you the version. Why that extra step?
This is another one of those interesting practical workarounds. You're right. Technically, a tool that doesn't need input shouldn't need an input schema.
Right.
But it seems some MCP clients might get a little confused or maybe even fail to recognize the tool properly if that schema is completely missing.
Huh. Okay.
So the author added a very basic, essentially empty input schema, just type string object, basically as a placeholder. It's like saying, yes, I acknowledge the concept of input, but I'm not actually expecting anything specific for this tool. It just helps ensure broader compatibility.
Got it. Another practical fix. So the tool is defined, name, description, schema. But how does the server actually tell an AI client, hey, I've got this Swift version tool you can use?
Ah, right. That's where the first handler comes in, with method handler, listtools.self.
Okay, list tools. Makes sense.
Yeah, this function defines how the server responds when an AI client specifically asks for a list of all the tools it has available.
So it's like the server's menu function.
Exactly.
Yeah.
You provide a bit of code inside this handle that returns a list tools result object. And in this case, that result object contains a list with just our one tool, the Swift version tool we defined.
So when a client connects and asks, what can you do? This handler kicks in and sends back the list containing Swift version and its description.
Precisely. It's the server offering its menu of capability.
Right, like a waiter listing the specials. Now, what happens when the client actually wants to use this Swift version tool? How does the server handle that request?
Okay, that's the other handler. With method handler, call tool.self.
Call tool, logical.
This handler gets triggered when an AI client sends a request to actually execute a specific tool.
And what does it do first?
Inside this handler, the first thing it does is a really important check. It looks at the params.name in the client's request. That's the name of the tool the client is asking to run. And it makes sure it exactly matches the name of our Swift version tool.
Why is that check so crucial?
Well, imagine a server that offers many different tools. You need to be absolutely sure you're running the correct one based on the client's request. If the names don't match, the handler sends back an error saying, essentially, I don't know that tool, or that's not the right tool name.
Makes perfect sense. You wouldn't want your get Swift version command to accidentally, I don't know, delete a file or something.
Exactly. So assuming the tool name does match.
Then what? How does it actually get the Swift version?
If the correct tool is requested, the handler then needs to return a call tool, result object. This object is what carries the actual output of the tool back to the client. And the output itself goes inside the results content array. In this specific case, the content is created using .text, meaning it's sending back plain text. And the value of that text comes from calling another function, a helper function called Swift version.
So the call tool handler basically says, okay, you want Swift version. Let me run the Swift version function and send you back whatever text it gives me.
That's exactly right. It delegates the actual work of getting the version to that helper function.
Okay, let's dive into that Swift version function itself then. How does it actually figure out the current Swift version on the system?
The Swift version function is pretty straightforward, actually. It uses a built-in Swift capability called process to run a command line instruction.
Like typing something in the terminal.
Exactly like that. It tells the system to find the Swift executable, the Swift compiler program, and run it with the version flag. That's the standard way to ask Swift for its version information on the command line.
Okay, so it runs the command. But how does our Swift program get the result back from that separate command line process?
Good question. It sets up something called a pipe. Think of a pipe like a temporary connection or channel between two different programs or processes.
Right.
Here, it creates a pipe and tells the process, the Swift version command, to send its standard output into that pipe instead of just printing it to the screen.
So it redirects the output.
Precisely. It assigns this pipe to the standard output of the process. Then it runs the command using process.run, and importantly, waits for it to finish using process.wait until exit.
Okay, it runs, it finishes.
And once it's done, our Swift code reads all the data that was sent through the pipe, the output from Swift version. Finally, it converts that raw data into a readable text format, specifically a UTF-8 string, which contains the Swift version information we want.
And it handles errors, too.
Yes, the code shown includes checks to handle potential errors, like if the Swift command couldn't be found or if running it failed for some reason. It tries to return an informative error message in those cases.
So it's basically automating what you do manually in the terminal. Run Swift version, grab the text output. Pretty neat.
Yep. A standard way to interact with command line tools from within a program.
Okay, so we've got the server set up, the tool defined, the handler's ready. And then after all that's set up in main.swift, there's a line that says server.wait until completed. Why is that important at the end?
Server.wait until completed. That's
Yeah.
crucial. Without that line, the Swift program would just run through all the setup steps, creating the server, setting up handlers, and then it would just stop. It would exit.
And the server wouldn't be running anymore.
Exactly. Wait until completed tells the main part of the program to just sit there and wait indefinitely. It keeps the server process alive in the background, actively listening for those incoming requests from MCP clients via the Studio transport.
So it's like keeping the phone line open, waiting for calls.
That's a good analogy.
Yeah.
It prevents the program from terminating immediately after setup.
Right, got to keep the lights on.
Right.
And then the article just briefly mentions running Swift build. That's just the standard step to compile everything, right?
It's exactly. Swift build is the command you run in your terminal in the project directory. It takes all the Swift code you've written, main.swift, package.swift, etc., and turns it into an actual executable file that your computer can run to start the MCP server.
Standard build process. Got it. Now, The author makes a quick side note. They felt the SDK's design might have taken some inspiration from TypeScript, which is interesting.
Yeah, a language popular in web development.
And that sometimes you might need to use more generic data structures like untyped dictionaries. But they also highlight that it supports modern Swift features like async await.
Right. That's kind of an interesting observation for developers using the SDK. It suggests that while some parts might feel familiar if you've used TypeScript or JavaScript, maybe how handlers or interfaces are structured, the Swift SDK still leverages powerful modern Swift features like async await.
And that helps with.
Async await makes it much easier and cleaner to write code that deals with things that might take time, like waiting for a network request, or in this case, waiting for the Swift version command to finish without blocking the whole server. It helps keep things responsive.
Okay, cool. So we've conceptually built this Swift version server. Now, how do we actually use it? The article focuses on connecting it to Visual Studio Code.
Yes, that's the next logical step. The article explains how to integrate this server we just built with a feature in VS Code called agent mode.
Agent mode, is that standard VS Code?
It's part of the GitHub Copilot extension, actually.
Okay.
So you need Copilot installed in VS Code for this specific integration method.
Ah, okay. Good to know.
And the process basically involves telling VS Code via the Copilot agent settings about our new MCP server so it knows it exists and how to talk to it.
Okay, walk me through it. What are the steps in VS Code?
Sure. First, you open the command palette. The shortcut is usually Command plus Shift plus P on Mac OS, or Shritroll plus Shift plus P on Windows Linux. Then you start typing MCP. And you should see an option like MCP list servers. You select that.
Okay, list servers.
From there, you'll likely see an option to add server. Click that. VS Code will then ask you what type of transport your server uses.
And for our Swift server.
Since our Swift server uses standard input and output, we choose the option labeled Command. Set a go.
Makes sense. Then what?
Then comes the crucial part. You need to tell VS Code where to find the actual program, the executable file that Swift build created.
Ah, the path.
Exactly. You'll be prompted to enter the full path to that executable. The article gives an example, something like users Hartenovichkov developer Swift -version -mcp.buildarm64 Apple macOS X debug Swift version -fb.
But that specific path won't work for me, right?
Absolutely not, unless you happen to be that author. It's really important to understand this path will be unique to your system, where you save the project, your username, your operating system, maybe even the architecture like ARM64, Apple macOS Ox. You need to navigate to your projects.build debug, or sometimes .build release folder, and find the executable file in there.
Okay, so definitely not a copy-paste job there. You need to find your own file path.
100%. You got to provide the correct path for your setup.
What happens after you give it the path?
After you've provided the path, VS Code will ask you to give the server a name. Something simple like a Swift version server, as suggested in the article, works fine. It's just a friendly label for you to recognize it within VS Code.
Okay, a nickname.
Yep. And finally, it usually asks whether you want to save this server configuration in your global user settings, making it available everywhere in VS Code, or just in the current project's workspace settings.
And where does that config get saved?
The article shows it ends up in a JSON file, either your main settings.json or a project-specific.vscodemcp.json. It shows an example snippet. It maps the friendly name, Swift version server, to its type, Stadio, and the command, that specific executable path you entered.
Right, so VS Code now knows about the server. How do you actually start it up within VS Code?
Okay, so if you go back to that MCP list servers view, using the command palette again, you should now see your newly added server, Swift version server, listed there.
Yeah.
Next to its name, there should be a little start button or icon. When you click this, VS Code actually runs the executable program using the path you provided.
And you should see something happen.
Yes. You should look at the VS Code output panel, usually selectable from the bottom panel. Find the drop-down for different output channels and look for one related to MCP or GitHub Copilot agent. The article shows example logs you might see there, messages indicating the server is starting, its connection state changing, and crucially a message like discovered one tools.
Ah, that's the confirmation. VS Code found the Swift version tool.
Exactly. That tells you VS Code has successfully connected to your running Swift server and understands the tool it offers.
Okay, amazing. VS Code knows the tool exists.
Yeah.
How do you actually use it within the Copilot chat interface?
Right, so you open the Copilot chat view. The shortcut mentioned is Control plus Command plus I maybe, or you can usually open it from the side panel.
Okay, chat's open.
In the chat input area, maybe near the top left, you should see a button or indicator, perhaps saying something like Select Tools
Yeah.
or maybe just showing an icon and a number. The article suggests it might show one config indicating one tool is available.
And if you click that,
Clicking that should show you a list of the available MCP tools that Copilot is aware of. You should see our Swift version tool listed there, possibly with its description. You might need to explicitly enable it for the current chat session.
okay, tool selected or enabled, now what?
Now, you can just ask a question in the chat naturally. Something like, what version of Swift am I using? Or, tell me the Swift version for this project.
And Copilot figures it out.
Copilot's agent, recognizing that your question relates to the Swift version and knowing that the Swift version tool is available and provides exactly that info, can then automatically send a call tool request to our running Swift MCP server in the background.
Our server runs Swift version,
Yep, our server gets the request, runs the command, gets the output string,
sends it back.
sends the result back to the Copilot agent, which then presents that information to you as part of the chat response.
That's really slick. It extends Copilot's knowledge right into my local environment using this custom tool.
Exactly. That's the power of MCP in action, even with this simple example.
Very cool. Now, the article also mentions briefly that you can use these MCP servers with other AI clients too, not just VS Code Copilot. It names things like Cursor, Windsurf, Claude, Desktop.
That's right. The principle is the same. MCP is designed to be an open standard, so different AI assistants or environments can potentially integrate with MCP servers.
Is the setup process similar for those other clients?
Generally, yes. The core idea remains consistent.
Yeah.
You need to tell the client application about your MCP server. You need to specify its type, like Studio, and provide the command or path to its executable program.
But the specifics might differ.
Yeah, the exact way you configure it will likely vary. The article gives an example for Cursor, where you edit a JSON file named .cursormcp.json in your user or project directory. The structure shown looks very similar to the VS Code 1 mapping a server name to its type and command.
Okay.
It also mentions Claude Desktop uses a similar configuration, likely in a file named claude.desktopconfig.json, but notes that you might need to restart the Claude Desktop application after adding the server for it to pick up the changes.
So similar concept, maybe slightly different file names or restart requirements depending on the client.
Exactly. But the fundamental principle of registering your Studio-based server program with the client holds true.
Got it. Okay, as we start to kind of wrap up our deep dive into this article and MCP, what are the main things we should really take away from this? What makes this whole MCP thing significant?
Well, I think the absolute key takeaway is that MCP provides a standardized mechanism for different applications to feed crucial real-time context to large language models.
Context is king.
It really is here. It allows the LLMs to move beyond their general training data and provide assistance that's much more relevant and, frankly, useful in your specific situation.
And the Swift server example.
That simple Swift version server, even though its function is trivial, perfectly illustrates the core principles. It shows how you can define a specific tool, advertise its capability using list tools, and then handle requests to execute that tool using call tool and return a result. It makes the abstract idea of MCP very concrete.
It demonstrates how you can bridge that gap we talked about at the start, connecting the LLM's power directly to your local environment and the tools you're using.
Precisely. It's about extending the LLM's reach and knowledge.
And the author of the article seems pretty excited about where MCP could go, right? They even speculated about potential future integration into Xcode.
Yeah, you can definitely sense the optimism. The potential for MCP to become a sort of fundamental layer for AI interaction within our software is quite significant, that mention of Xcode integration.
Purely speculative, of course.
Oh yeah, definitely speculation at this point. But it really hints at the kind of transformative impact MCP could have, especially on developer workflows. Imagine AI assistants being deeply embedded and context-aware right within your main development tools.
That would be a game changer.
It really could be.
And for anyone listening who wants to actually try this out or dig deeper, the article provides a link to the final code on GitHub.
Yep, which is great. It encourages people to explore, maybe tweak it, or use it as a starting point for their own MCP servers.
And it also lists some helpful references at the end.
Yeah, links to more info about the model context protocol itself, how it's used in VS Code agent mode and Cursor, and even a link to an awesome MCP servers list, which collects other examples people have built.
So plenty of resources to follow up with.
Definitely. Those are valuable for anyone wanting to understand the specs better, see more examples, or just get a feel for the growing ecosystem around this.
Okay, so to quickly summarize our deep dive then, We've explored the Model Context Protocol, MCP, as this open standard aiming to give LLMs the specific context they need from our applications to be smarter and more helpful. We walked through a very practical example, building a basic Swift server to report the Swift version, seeing the core mechanics of defining tools and handling requests.
Yeah, the list tools and call tool handlers.
Exactly. And we saw how you can connect this server to an AI client like VS Code's Copilot agent, allowing the AI to leverage this new localized capability.
Making the AI assistant more powerful in that specific context.
Right. It's pretty clear that MCP, or ideas like it, really hold the potential to significantly change how we interact with AI, weaving it much more effectively into our development workflows and productivity tools by making those interactions way more informed.
Absolutely. By creating this standardized pipeline for context to flow from our applications to our AI assistants, MCP is really laying some important groundwork. It paves the way for a future where AI feels less like a separate thing you consult and more like a deeply integrated, contextually aware partner in whatever you're doing.
A true digital collaborator. Okay, on that note, here's a final thought for you, the listener, to kind of chew on. We've seen how even simple context, like a software version, can enhance an LLM via MCP. Now think bigger. What other kinds of data, what other application integrations, maybe things that seem unrelated at first, could significantly unlock new levels of capability for LLMs if they were brought together through MCP or similar standards? What connections could lead to truly groundbreaking AI assistants we haven't even thought of yet?